I'm Dr.B.Krishnaveni, Assistant Professor in Department of Mathematics, Aditya University. Today we are going to discuss about mean value theorems. So in specific, we are discussing about how to apply Cauchy mean value theorem. So to go into the theorem, first we need basics also. That also we will discuss in this lecture. So now what the learning outcome of this lecture is, student will be able to apply Cauchy's mean value theorem. So for that, first we need the continuity of a function. So what meant by continuity of a function is, continuity of a function is defined as a function f of x is said to be continuous at a point x is equal to a if limit extends to a f of x exists and is equal to f of a. That is, we can write this as limit extends to a f of x is equal to f of a, then we say that the function is continuous at x is equal to a. So now when we say that the function is continuous in an interval, if it is continuous at each and every point in that interval, we say that it is continuous in that interval. Suppose let us consider an interval closed a comma b. So now at each and every point we are getting a limit and satisfying this, we say that it is continuous in the given interval. So that is limit extends to c f of x is equal to f of c, where c belongs to closed a comma b is an arbitrary point. So now what the properties of continuous function? If we consider two functions f of x and g of x which are continuous function, then f of x plus g of x as well f of x minus g of x are continuous, f of x into g of x is also continuous. Now, if f of x and g of x are continuous functions means, then f of x by g of x is also continuous provided g of x not equal to 0 for all x. So, in other words, we can say that if f and g are continuous means f plus g, f minus g, f into g are also continuous, and f by g is also continuous provided denominator not equal to 0 for all x. So, now this is the points which you have to keep in mind to do the questions. So, for this are all the universal facts which were continuous, always continuous. So, hence if we are given any function in this way means directly we write those are continuous function without verifying anything, right. So, here all polynomial functions continuous everywhere. Similarly, the functions sin x, cos x are continuous everywhere. Similarly, exponential functions are also continuous everywhere. And the function log x is continuous on this interval. So, that means it is not continuous for 0 and negative values and open infinity. The next one is differentiability of a function. The function f of x is said to be differentiable at a point x is equal to a if limit extends to a f of x minus f of a by x minus a exists and the limit is denoted by f dash a. So, that means we can write the definition in this form, that is f dash a is equal to limit extends to a f of x minus f of a by x minus a. A function f of x is said to be differentiable in an interval closed a comma b if it is derivable at each and every point in that interval. So, we say just as the continuity, we have defined the differentiability at a point and the differentiability in an interval. So, now let us move to the main topic of this lecture, that is Cauchy's mean value theorem. We have the statement for this, that is given by, if f maps closed a comma b to r and g maps closed a comma b to r are two functions such that f and g are continuous on closed interval a comma b, f and g are derivable on open interval a comma b, and g dash x not equal to 0 for all x belongs to open a comma b, then there exists c belongs to open a comma b such that f of b minus f of a by g of b minus g of a is equal to f dash c by g dash c. So, this gives the statement for Cauchy mean value theorem. So, let us see once again the statement. Thereafter, we will move to the question, that is how to apply Cauchy mean value theorem. Let us consider two functions f g from closed a comma b to r. If f g are continuous on closed a comma b, f g are derivable on open a comma b, and g dash x not equal to 0 for all x belongs to open a comma b, then there exists c belongs to open a comma b such that satisfying the condition, that is f of b minus f of a by g of b minus g of a is equal to f dash c by g dash. So now let us apply Cauchy mean value theorem. The first question is verify Cauchy's mean value theorem for f of x is equal to x square, g of x is equal to x cube in closed interval 1 comma 2. So now given f of x, x square and g of x is equal to x cube in the what interval is closed 1 comma 2. Now need to check whether it is continuous in the closed interval, derivable in the open interval. Thereafter we will apply Cauchy mean value theorem. So hence clearly f and g are polynomial function and we know that both are continuous everywhere. So hence f and g are continuous in closed 1 comma 2. As well, if you do the derivatives, those are also defined. Hence those are derivable on open 1 comma 2. Clearly g dash x, what is g dash x is equal to 3x square, and you can verify the value for each and every value in the open interval 1 comma 2. It is not equal to 0 for every value. Hence the third condition is also satisfied, and taken f dash x which is the 2x. So hence by Cauchy mean value theorem we will get at least one c belongs to 1 comma 2 such that f dash c by g dash is equal to f of 2 minus f of 1 by g of 2 minus g of 1. So now what f dash x is 2x. So hence f dash c is a 2c divided by g dash c. G dash x is 3x square which is 3c square is equal to do f of 2 that is a 4, 2 square 4 minus f of 1 that is a 1 divided by g of 2 which is 8, 2 cube 8 minus 1 that is 3 by 7. So simplify to find the value of c. We got c is equal to 14 by 9 here and is clearly belongs to open 1 comma 2. So hence we can say that Cauchy mean value theorem is verified. So this is the way to verify Cauchy mean value theorem. What we will do is we will take f g and check the continuity in the closed interval in the given closed interval and check the differentiability in the given open interval and check g dash x not equal to 0 for every x in the open interval. Then we will take the condition of Cauchy mean value theorem and find out c, and that c must be in the interval open 1 comma 2. So hence once it's satisfying this means we will say that the Cauchy mean value theorem is verified. Now move to the second question. The second question is find the value of a c of the Cauchy mean value theorem for f of x is equal to e power x, g of x is equal to e power minus x in closed interval a comma b. So here you may see the question in different form, but the problem solution is same as the previous question. So here also you need to do the same conditions. First need to check the continuity, differentiability and g dash x not equal to 0 in the open interval. Thereafter find out the c and that c must be in the open given interval. So let us proceed. Given f of x is equal to e power x and g of x is equal to e power minus x in closed a comma b. And it is very clear that f of x and g of x continues since they are exponential and we know that they are continuous everywhere. So hence we say that it is continuous on closed interval a comma b. Similarly they are defined, their derivatives are also defined, hence they are derivable on open a comma b. So now find out g dash x, that is minus e power minus x it is, and is not at all equal to 0 for every closed interval a comma b. And here what is f dash x is e power x derivative is e power x. So satisfied all the three conditions, hence apply Cauchy mean value theorem. There exists c belongs to b such that f dash c by g dash c is equal to f of b minus f of a by g of b minus g of a. So f dash c. So what is f dash is? F dash x is e power x. F dash c by g dash c means e power c by g dash c, that is minus e power minus c is equal to f of b minus f of a. What is f of x is e power x. F of b minus f of a means e power b minus e power a divided by g of b minus g of a, that is e power minus b minus e power minus c. Simplify this to find out the C value, and you got C is equal to A plus B by 2. And clearly it is the midpoint of AB which belongs to open interval A comma. So here in this question, the theorem is verified and we got the C is equal to A plus B by 2, which belongs to open interval A comma B. So hence in this lecture what we learn is how to apply Cauchy mean value theorem. And we have done with the examples also. The one is how to verify and how to find the value of a C. Almost the same both the questions, but we discussed how to apply Cauchy mean value theorem for the given problems. Thank you.